All right, section 7.3, estimating a population proportion. Let me start the slideshow. All right, back in 7.1 and in 7.2, our job was to come up with an error and also a confidence interval. All right, and what we're trying to do here is estimate the population mean mu. And we wanted a confidence interval that we were 90 or 95% confident that the actual population mean mu fell within a low number and a high number. In section 7.2, we didn't know what sigma was. We knew what S was, the standard deviation of the sample. Instead of using z-scores, we were using t-distributions, which meant we had to go to a chart, subtract 1 from n, figure out the degrees of freedom, and find this t-score. In either both cases, our calculator was able to find this confidence interval for us. But that's the difference here. We were trying to estimate the population mean mu. All right, so how do things change? Well, in section 7.3, we're now trying to estimate a population proportion. So we still need to find an error, and our point estimate is going to be called something called p hat. We're going to subtract the error from p hat to find a lower bound and add the error to the p hat, this point estimate, to find the upper level. We still need to calculate an error. It's a little different. What's different about this is you have to know what p hat and q hat are. Sometimes you have to calculate p hat. And once you know that, you subtract that from 1 and you know q hat. Many times p hat is given to you. And here again, once again, to find q hat, you're going to subtract from 1. Good news is that we're back to z-scores. And I gave you 12 different values, depending on what percent confidence level you wanted to be at. I gave you all the 14 z-scores. So that's a break here. This becomes a little more work in calculating p hat and q hat and calculating the error. Estimating a population proportion. All right, in this section we present methods for using a sample proportion called p hat. It's a little sort of an upside down V. Now you're saying to yourself, well, why didn't they call it P bar? They called it X bar before. Well, I don't know the answer to that. They call it p hat. This the proportion of the sample is the estimate of the population proportion p, just like X bar was the best point estimate to the population mean mu. P hat to p used to be X bar to mu. That's the difference in section 7.3. Sample proportion is the best estimate, just like X bar was the best point estimate back in 7.1 and 7.2. We can use sample proportions to construct a confidence interval, just like we did 7.1 and 7.2. And also, we're going to be interested in finding out the sample size. Hey, how big of a sample do I need to take in order to be 95% confident, 96% confident? We had this back in 7.1. 7.2 did not talk about. Well, I take that back. 7.2 did talk about sample size. They both did 7.1 and 7.2. And 7.3 continues on. All right. So what does it mean to proportion, sample proportion, population proportion? Although the section focuses on the population proportion P, we can also work with probabilities and percentages. What they're saying is a proportion can be expressed as a probability or even a percentage. For example, if 70% of the people polled believe in global warming, this statistic 70% can be expressed as a decimal, 0.70. In this case here, p hat would be 0.70, q hat would be 1 minus 0.70, 0.30. If we want to estimate a population proportion with a single value, the best point estimate is this p hat. It's the sample, the proportion of the sample we'll use to come up with a confidence interval for p, the proportion of the entire population. Simply stated, this slide kind of really summarizes it all. You have a random sample of 188 books. purchased at a local bookstore, and 66 of these books were murder mysteries. Let P represent the proportion of books sold by this store that are all murder mysteries. What's the best point estimate for P? It's P hat. It's R over N. Now remember, R and X are one and the same. All right. So to find the proportion of the sample, it's like finding a probability. It's favorable over total. All right. 0.35. All right. 35 hundredths of all the 188 books were books on murder mysteries, or you could say 35%. So here's the formula for error. It's a z-score. Well, in this case here, if we want to be 90% confident, we realize that 90% has a z-score, critical value of 1.645. That's on a slide that lists 14 of them. P hat we just calculated to be 0.35. Q hat is 1 minus 0.35, and that's all divided by the square root of 188. Of course, you're taking the square root of that. And correct to 4 decimal places, 0.0572. So here I would take my P hat, I would subtract my error, take my P hat, and I would have my error. Prior to this in 7.1 and 7.2, we're taking X bar, subtracting the error, and X bar, adding the error. And of course, our calculator had a sort of an app that did it all for us and still does. All right, so what's the interpretation here? The interpretation, if I can move this out of the way, if we had computed the interval for many different sets of 188 books, we would have found that 90% of these intervals would actually contain P, the population proportion of mysteries. Consequently, we can be 90% confident that our interval, this interval right here, all right, is the one that contains the unknown value for P. It's between 0.29 and 0.41. In other words, between 29% and 41% of all the books sold by this particular bookstore were books about murder mysteries, between 29 and 41%. Quite a range there, but if you want to be more precise, this range is going to get even larger and larger. Move this out of the way. All right, once again, the sample proportion P hat is the best estimate for the proportion, for the population proportion P, just like X bar was the best estimate for mu, X bar being the mean of the sample and mu being the mean of the population. Here it's P hat and P. P hat is R over N. Sometimes P hat is actually given to you. If you don't know what it is, it's R over N. R and X are one and the same. And of course, Q hat is 1 minus P hat. R and X on a TI are synonymous. All right, so this goes back to, how do you find these critical values? We did this back in 7.1. I flat out gave it to you. If you're looking for a 95% confidence level, your critical value, your z-score is 1.96. We know how to do that. And there's this magic slide that I'm talking about. Let me go back to it. All right, these are the 14 that I'm giving you. This little rectangle should have been slid over. For 99%, you're using 2.575. This should have been slid over to hide that. And then there are 6 more of them, 2, 4, there's 6 more given to you there. Make sure you have this because you're going to need it for 7.1 and you're going to need it for this section 7.3. All right, once again, there's the formulas, how to find your error. Once you know P hat, Q hat is 1 minus P hat. All right, once again, here again, all the different variables that we use. P is the population proportion, P hat is the sample proportion, and number of sample values. X is the same as our number of successes, and E is the margin of error, and you know all the critical values. And that's what we're looking for, a confidence interval, where my error is given to me right here. Example, if we note in a Pew Research poll that 1,501 randomly selected U.S. adults, it showed that 70% of these respondents believe in global warming. So N is 1501. P hat here is given to us, right? It's not the previous example where we had to put the number of murder mysteries over the total number of books. He just flat out tells me what P hat is. And we want to construct a 95% confidence interval, all right, for the true population proportion P. All right, so first thing I'm doing here is calculating the error. So if I'm looking for a 95% confidence interval, then I know my z-score is 1.96. He flat out told me what p hat was, 0.70. Therefore, q hat is 1 minus that, 0.30. He tells me what n is. All right, pretty nice because he gives me all the values I need. All I do is subtract to find q hat. He's got it correct to a bunch of places, 2, 4, 6 places. All right. So what he's going to do now is take this p hat, subtract the error, take p hat, and add the error, and come up with a confidence interval between 0.677 and 0.723. Based upon this confidence interval, it does appear that the proportion of adults who believe in global warming is greater than 50%. So we can safely conclude that the majority of adults believe in global warming. Because the limits 0.677 and 723 are likely to contain the true population proportion, it appears that the population proportion is a value greater than 0.5. Well, obviously, 0.677 and 0.723. The true population proportion lies between these two numbers. Both are obviously the lower one is bigger than 0.5, so we can assume that the majority of adults do indeed believe in global warming, which is neat. All right, so that's doing it pencil and paper, but obviously our calculator bails us out. Here's what we're doing. Prior to this, in 7.1, we went to stats test. We came down to number 7. In 7.2, we went stat test. We came down to number 8. To find a confidence interval for the population proportion P, we're still going to stat, we're going to test, but now we're coming down to letter A, 1 prop Z interval. All right, so we've used 7, we've used 8, now we're skipping 9 and 0, we're coming down to letter A. X value, well, I took 70% of 1501. This has to be a whole number. All right, so I rounded to the nearest whole number. 70% of 1501 was 1051. N was given to me as 1501. I'm looking for a 95% confidence level. And once again, I'm putting in 95. You could have put in 0.95. The calculator doesn't mind. Either one is fine. Hit calculate, and there's what my calculator is giving me. Exactly the same thing we did pencil and paper, finding the error and subtracting and adding to p hat. Spot on, 0.677. 0.723. Pretty nice. All right. So I start out by working with 3 examples to first, even on the exam, I've done this right along. We start out by finding the error, then I give you problems where I actually want the interval, and then I'm looking for sample size. Well, the same thing happens in 7.3. We start out calculating the error, and then we'll go to the confidence interval, and then finally sample size. All right, so number 1, he says, hey, find a margin of error that corresponds to these given stats. We want to be 95% confident. And my n value is 320. My x value is 60. He's not telling me what p hat is. I got to solve for it. P hat is the number of successes over the total. All right, so it's 60 divided by 320. My x value divided by n. I would strongly advise making this correct at least 3 decimal places. So doing the division here, p hat comes out to be 0.188. Therefore, q hat is 1 minus that, or 0.812. Well, once I know p hat and q hat, I already know that a 95% confidence interval, my z-score is 1.96. All right, there it is, 95%, 196. So in place of my z-score, I'm putting in 196. I put this in parentheses. You didn't have to. If you don't use parentheses, you got to use a time sign right here. It's times the square root of p hat, which is 1.88 times Q hat, which is 0.812. What you're not seeing is the division sign and dividing by n, which is 320. You're not seeing the back end of this because the calculator is limited to the space. Bottom line is 0.0428 is the error, and you can see it's right on the money. Number two, same type of problem. Once again, you're looking for a 99% confidence interval. Confidence level, excuse me. Your n value is 6,500 and your x value is 1950. He's not telling me what p hat is. I got to solve it myself by putting x over n. 1950 over 6,500. My calculator tells me it's 0.300. Therefore, q is 1 minus that 0.700. For a 99% confidence level, I know my z-score is 2.575. That's from the chart. So in place of z, there's my 2.575 times, here I didn't use parentheses, times the square root of p hat. I don't know, instead of putting in 0.300, I just simply put in 0.3. Instead of using 0.700, I use 0.7, same thing. Divided by my n value, which is 6,500. You're not seeing all of it here. And hitting enter, 0.0146. Here we get right on the money. Calculator gives me the exact answer. All right, this one becomes a little bit easier because now I'm telling you, you have 25% with successes. All right, you know he's giving me p hat. There's no division. Excuse me, I don't have to divide x by n. I know what p hat is. Well, if I know what p hat is, I know what q hat is. It's 1 minus 0.25, 0.75. Looking for a 98% confidence level. The z-score associated with that is 2.33. So my z is 2.33 times the square root of p hat, 0.25, times q hat, 0.75, divided by n. And n is given to me here as 880. So you're not seeing you're not seeing the 8 and the 0 because of the limitation of the calculator. All right, pressing enter, you can see the answer is right on the money, 0.0340. All right, so much for finding error. And now, as was the case in 7.1 and 7.2, I now want the confidence level. All right, confidence level. I know it'd be 95%. I want the entire interval. Well, there's no need of me finding error and subtracting and adding it to p hat. My calculator will take care of this. Go to stat, go to arrow over to test, come down to letter A, one proportional z interval. This couldn't be any easier. It just only wants three values. All right, and the problem tells you all three values. Your x value is 27, your n value is 51, your confidence level is 95%. Three numbers, but the three numbers are given to you. Put them into the calculator, hit enter, and it repeats p hat and n to you, right? Well, actually, it repeats n. You wouldn't have known what p hat is. Who cares? The important thing is it gives you the interval between 0.392 and 0.666, and there it is. There it is, spot on. Same thing for number two. I'm not even sure why I'm doing so many of these because when you go to stat test, come down to letter A, one proportional z interval. It requires three inputs, but the inputs are just given to you. And there they are. Your x is 55, your n is 110, your level is 88. I'm using 88 instead of 0.88, same thing. And look at the interval, 0.426 on the low end, 0.574 on the high end, letter D. And I did one more of these. Once again, the values are all given to you, 122, 164, 95. And the answer is exactly what you would expect the answer to be. There's no discrepancies here. Okay, so we found the error, and then we actually found the interval. Suppose we want to collect sample data in order to estimate some population proportion, The question is, how many sample items must be obtained? What must n be? How many samples do I need to be X amount of confident that some proportion is going to take place? All right, so if I take the error formula, just like we've done in previous sections, and do some algebra, I come up with a formula for n. All right, n is equal to the z-score squared times p hat times q hat divided by the error squared. Now, the algebra is not a big deal, but there's no need of proving this. Taking this formula, solving for n, this is what we come up with. All right, and once again, you need to have this formula. In fact, there's going to be two of them. Two things. Sometimes p hat is known. All right, if p hat is known, this is the formula you're going to use. If p hat is, I'm sorry, if p hat, this should read, my bad here. All right, when no estimate, I should take back, now I get it right. When no estimate of p hat is known, in other words, p hat is not given to you. So you're saying, well, if p hat's not given to me, how are they coming up with 0.25? Well, if you don't know what p hat is and q hat, if you don't know what p hat is, you don't know what q hat is. All right, so what the authors do here, they just use 0.5 for p hat and they use 0.5 for q hat. All right, if they don't know what it is, we just say, hey, 0.5, 50, 50, 0.5, 0.5. Now, 0.5 times 0.5, this is where they're coming up with this 0.25. If you don't know p hat, you don't know q hat, you use 0.5 for both of them. 0.5 times 0.5 gives you 0.25. This is when you don't know p hat. When you do know p hat, you'll put it here, you'll solve for q hat. If you don't know it, you use 0.25 for the product. All right. If the computer sample size is not a whole number, just like in section 7.1 and 7.2, we always round up. No matter what the decimal is, we always round up to the next whole number. The internet is affecting us all in many different ways. There are so many reasons for estimating the proportion of adults who use it. Assume the manager of eBay wants to determine the current percentage of U.S. adults who now use the internet. How many adults must be surveyed in order to be 95% confident? All right, that the error is no more than 3 percentage points. All right, so part A, he's telling me p hat. In part B, he's not telling me p hat. All right, part A, he's telling me 73% of the adults. He's giving me p hat here. He's not telling me anything in letter B. So let's do letter A first. So in letter A, he's telling me p hat is 73% or 0.73. All right, 73%, 0.73. Well, therefore, q hat is 1 minus that 0.27. We're looking for a 95% confidence. We want to be 95% confident, so my z-score associated with 95% is 1.96. We want to be within 3 percentage points. There's the error. He says it right here. The sample percentage is no more than 3 percentage points. 3 percentage points, 0.03. All right, so I know this value, 0.196. I'm squaring it. There's my p hat. There's my q hat, and I'm dividing this by my error squared. And I'm rounding up, even though this is a 0.3, I'm rounding up to the next highest number, 842. That's my sample size that I need. Let me go back here. To be 95% confident, we've got to survey 1,068 adults. All right. I kind of did. I went a little fast here. All right. So let's assume part B now, we don't know what p hat is and q hat. Here we were told that p hat was 73%, 0.73. So in part B, we don't know what p hat is. If we don't know what p hat is, we use 0.5 for p hat and 0.5 for q hat. So when I do my multiplication here, when I multiply 0.5 times 0.5, that's where I'm coming up with this 0.25. This is the product of 0.5 and 0.5. So there's my z-score as it was before, associated with 95%. The product of p hat and q hat is 0.25. There's my error, and my formula says for me to square it. And then, of course, I take 1,067.111. I round it up to the next highest number, 1,068. So I've got to sample 1,068 people to be 95% confident. All right, so the remaining problems here are just me doing it with the calculator. My margin of error is given to me as 0.004. If I'm missing the formula here, okay, let me put that in so we all see it. P hat, I want to be 95% confident. P hat and Q hat are unknown. That's where I'm using this 0.25 here. If I knew what P hat and Q hat was, I would put the product here. Since I don't know, I use 0.5, both of them, so the product is 0.25. The z-score associated with 95% is 1.96 times 0.25. There it is here, divided by the error squared. All right, so your calculator is very adept at doing this. Notice I don't need any parentheses. The calculator knows knows art of operations. It's going to square first and do the multiplication and do the division. Make sure you're squaring your z-score and you're squaring your error here. All right, the answer came out to be 60,025, a remainder of 0, so there's no need of rounding up. But notice there's nothing around. I didn't give you 60,025 and 60,026. All right, pretty obvious what the answer was. Same thing here. You're given, you don't know what P hat and Q hat are. You do know the error is 0.015. You're looking for a 96% confidence level. All right, the z-score that's associated with 96%, we haven't used as much as 2.05, and I'm squaring it times, since we don't know what P hat and Q hat are, the product of the two is 0.25. We're using 0.5 for each of them, divided by the error squared. He tells me here's the error, and I'm making sure that I'm squaring it. I don't need any parentheses. 4,669, rounded up to the next highest number. Whole number is 4,670. All right, so here's now nothing even close. I wasn't even playing any games here. All right, that rounds up to the next highest number. No big deal. This one here, we do know what P hat is. We know margin of error. We have a confidence level. We want to be 95% confident. P hat is estimated as 52%. So P hat is 0.52, 52%. Well, P hat is 0.52, then Q hat is 1 minus that 0.48. All right, so my z-score is 1.96. I'm squaring it. P hat times Q hat, 0.52 times 0.48. 52% is my P hat. As a decimal, it's that. Divided by the error is 0.01, and making sure that I square that. All right, you can't see it over here because here we go, the limitation of the screen. 9,588.6, rounded up to the next highest number, 9,589. And then the last one here, you want to be 99% confident. So the z-score that's associated with 99% is 2.575. There it is, 2.575. I'm told to square that. P hat times Q hat. Well, he tells me P hat is estimated as 0.15. Well, if P hat is 0.15, Q hat is 1 minus 0.15 or 0.85 divided by the error square. The error is 0.05. You can't see it, but I'm squaring it. Hitting enter, 338.2, rounded to the next highest number is 339. And that is the end of that. Okay, hope that helps.